Hello, data community, and welcome to another episode of the DataRobot podcast. With me this week, we have Dr. John Hawkins. He is a lead data scientist at the DataRobot company for Australia and New Zealand. And he's also an affiliate researcher with the Center of Translation Data Science in Sydney University. He has a background in software development and philosophy. He has been applying machine learning, statistics, and other data mining techniques to a diverse range of data sets for the past 15 years. And I'm very excited to have him here today talking to me about the challenges of being a data scientist in 2020, especially under this pandemic situation. So we are going to be talking about what data science is, what it's supposed to do, and how you can become a data scientist if that's something that you want to pursue as your career, how John has developed his skills during the years. We are going to be talking about some tips and recommendations for those just getting started. We are going to be talking about DataRobot as well, and some recommendations in terms of books and literature that you can follow. Make sure you follow Dr. John on some of the links below on LinkedIn, on Twitter, and GitHub. I just received some news from DataRobot, and they are gonna be providing the Data Squad podcast some giveaways for you guys. So if you want to enter the giveaway, just put your check the link below and put your details, and we are giving away one DataRobot T-shirt and one ticket for a 3 days online training from the DataRobot University. It's a great opportunity. This course is valued at $1,000, and you can get it for free. No matter where you are in the world, make sure you enter your details to participate. I will be picking up a winner on the 1st of July, 10 a.m. Australian Standard Time. And then, of course, we are going to be announcing it on LinkedIn and contacting the winner. So these are great news. This is the first giveaway of the Data Squad Academy. So make sure you enter your details below. And now enjoy the podcast. I will see you next week. Bye-bye. Welcome to another episode of the podcast. We have Dr. John Hawkins today, and he is one of the leader data scientists in Australia. And we are going to have a conversation about the challenges of being a data scientist in 2020. So welcome, John. Happy to have you here.
Wonderful. Thank you for inviting me. It's great.
That's awesome. Thank you for taking your time. I know you're a busy person, and we appreciate that you are taking a few minutes to talk to us. So let me start by asking a little more about your experience and how you come to be a data scientist, why you choose that as a career path and all of that.
Yeah, sure. So my career path was kind of unusual. I mean, maybe all data scientists have unusual career paths. I sort of started off in computer engineering, dropped out to be a musician, played in and got interested in philosophy, started studying philosophy, and happened to have a couple of professors who were very, very into AI and neural networks and whatnot. So I started studying the philosophy of cognitive science and AI, by the end of which I was determined to be that AI and machine learning was what I wanted to do. So I went off and did a sort of an IT qualification to get programming skills, started doing maths and molecular biology, and eventually got a scholarship to do a PhD in applied machine learning. Spent a fair bit of time doing that, sort of doing applied machine learning research for what's called bioinformatics, which is basically understanding what you can learn about biology from protein and DNA sequences. So predicting functions of proteins, predicting where proteins move about in the cells. And then when I came out of academia, I, like a lot of sort of data scientists who first come in the industry, I worked in ad tech, so predicting who's going to click on what. And then I've kind of moved around and done a bunch of different things in sort of in banking and now with DataRobot, I get to work with all kinds of clients, so across all industries.
I saw in your profile that you were also an affiliate researcher at the University of Sydney. Is that still something that you're pursuing or doing?
Yeah, I'm not currently doing that actually. That's something I need to
You
update
have
on.
to update your CV.
That's finished. Well, so I'm still in contact with the people I was working with there. The main guy I was working with has now moved on to UNSW. So I would love to do some work with him. But at the moment, I just don't have any
So
time.
I saw that you were working on this project on basically forecasting air pollution or something like that.
Yeah, so the several people I'd got in contact with there were sort of specialists in Bayesian statistics and Bayesian modeling, which is something that I'd had a side interest in for a while. So I was reading their papers, working through their code, and developing a kind of a side project to apply new techniques to forecasting air pollution, and that's sort of on the back burner for the moment.
And that's great. Thank you for the background. And how do you see your career or yourself progressing in the next few years?
Yeah, that's it's really hard to say. Actually, no, sorry. Well, there are several things that I think this is kind of all wound up, I guess, with where data science kind of seems to be going. I think, we had a conversation a couple of weeks ago.
A couple of weeks ago, yeah.
So I think one of the things that will happen with data science is as the field matures, and in particular technology make it easier to solve certain kinds of problems, so there's less requirement for detailed work by data scientists. The data science work will kind of move up, either up the value chain or up the complexity chain. So I think there's potentially moving forward a lot of work for simulation and optimization kind of problem data science, which is something that's not enough is done at the moment, as well as, I guess, all the kinds of things we're starting to see with greater and greater application of techniques that can deal with really, really unstructured.
Yeah, I've seen a lot of people talking and kind of moving from data science to more machine learning and AI and this concept. And it's difficult to know if it is just a buzzword people are using, to attract customers or to move to another job, or it's a real need in the market for those kind of techniques.
Yeah, it's hard to say, right? Like it's, projects are started for all kinds of reasons. Some of them serve the interests of the organization. Some of them serve the interests of the people who are starting the project.
Yeah.
So, and a part of it is people just don't know. People don't know what's possible yet. So I think we'll probably go through multiple rounds of refinement where organizations go, yeah, well, we built up this team and it's not really doing what we thought it was going to do. So we'll focus those resources elsewhere. Yeah, I mean, we've seen some rounds of that already. I think there was an anecdote out of the US of an organization that hired a large team of data scientists, but then cutting 2/3 of them at least.
Wow.
They just weren't getting the results
because they were not giving the result expected. John, how can someone get started, especially with DataRobot or machine learning or all of these concepts that are new to so many people, including myself? How can we get around this and get started?
Yeah, so I mean, we've spoken a lot about data scientists and how tools help them, and how people can get into data science. But there's like any new technology, there's a group of people out there who just want to use it for what it's good for, and they're not necessarily interested in becoming specialists. So we've kind of seen that in the data prep and the visualization world to some extent. So one of the key ideas of the founders of DataRobot was that we should see how far we can make machine learning accessible to people who are like subject matter experts. So if you know your business, your industry, or the kind of domain you work in really, really well, and you understand its data, and then you can frame a problem, then you can use machine learning. And the reason I say frame a problem is because one of the little kind of twists that people need to go through mentally to make the transition from, say, BI world to machine learning is that the way you shape the data set affects the kinds of questions you can ask of it. So typically, if you in a reporting perspective, usually you might have, for this period of time, either a month or a week or quarter, you'll have some summary statistics about what happened that could be maybe broken down by different dimensions.
Correct.
But you're visualizing data by a sliver of a time period and everything that covers that time period.
Correct.
Whereas when you're looking to build a machine learning data set, it's kind of like you're asking a question. You're saying, here's this thing that we want to be able to predict, and here's all of the things that we think are related to that would help us make that prediction. And often those things are separated by time. So you might be saying, here's all the things we know about our customers at the start of the year. We then want to predict, will they cancel their subscriptions in the next 6 months? So the data point you're predicting is separated in time from the things that you know. And the way you prepare that data set determines the question you can ask. It says, what are the things that we could possibly use to know that
so basically you work backwards. You start with the question or with the prediction that you want to make, and then you go backwards and start collecting all the parameters and the data that you need to build a model to then create that prediction, right?
Yeah, exactly. And then so you create the prediction, and then you can either simply use that prediction in a kind of a blind way. You say, look, let's just make these predictions. Or you can say, okay, now let's interrogate the model and understand what it uses to make those predictions. And that's where a lot of BI people start to see value in a product like DataRobot. So the idea is you can go in and see, I've framed this data to ask these specific questions, and then I can say, like, how much does price, how much does service outages, how much does sort of the features we've added, the things that we've been doing on our side, how much does that affect the customer's decisions and outcomes?
And then how can someone do that today, let's say without DataRobot? How will go about and do that?
So, I mean, typically it means writing code, right? So the method of doing that that's well entrenched in industry is building what's effectively known as a linear model, which means that you create some kind of formula that says, this amount of X plus this amount of Y plus this amount of Z equals the probability, equals some quantity of expected, like the expected amount that the customer is going to spend, for example.
Okay.
And then, so there's a whole sort of system of education and, in fact, like enablement across organizations for understanding and interpreting those kind of models. That those numbers in front of the X, Y's and Z's are what are called in machine learning speak the features, which basically means the bits of information that you know about the customer, or in statistics terms, they're the independent variables, the things that you know that are separate from what you're trying to predict. And the numbers in front of them are called the coefficients, and the bigger the coefficient, the more important that particular thing is, or the stronger the contribution. So that's
the weight.
Yeah, the weight, exactly. So that's, in a kind of a nutshell, the way that those interpretations have been made. The upside of that is that when everyone's using the same model and everyone knows how to interpret it, there's a degree of transparency. But of course, the problem is that you're then restricted to only one way of building and answering these kind of questions. So one of the things that the machine learning world in general has struggled with is to come up with alternative versions of that, a way that anyone, whether you're building a neural network or a support vector machine or an ensemble of trees, a way that people can answer the similar kinds of questions. So there's a massive developing field of what they call explainable AI. But DataRobot has spent a lot of time building tools that allow people to answer those kinds of questions in a standardized way, regardless of what the model is that you're using.
So let's say someone with no machine learning, no coding expertise, will just go ahead and buy that robot tomorrow. Will they be still able to do something like complex like this? or
Yeah, absolutely.
it
So the
requires some kind of, background in programming or coding?
No. Yeah. No, the idea, I mean, we do have to run, we run training and enablement courses.
Okay, great.
So that people can sort of, because that thing I spoke about at the start there about understanding the change of mindset about how you frame the data. So you need data preparation skills. And if we can guide you through that change in mindset, then you can prepare a data, but you don't need to do the coding. So the idea is then the machine DataRobot's an automated platform which will explore a wide variety of models and show you those same standardized insights into what's driving them across all those models, and you can choose what works for you.
That's very interesting, because then that means you are removing that barrier, right? That for so many of us, we are kind of afraid of jumping to the data science world, because it's usually full of people with statistic background, mathematicians. So it's a realm of on its own, and it's quite hard to get into. And for me, I don't want to go back to the uni and start studying all the stuff again and become a developer of programming. But now that you are just saying that, it's not required, I'm more open to maybe use it, download it, give it a try, maybe present it in some customer that I'm working with, and build some kind of modeling. So it's interesting. Yeah, it's
very interesting. And the only other thing I'd add on that is that actually this kind of standardized method of understanding the models, it's also useful for management, because one of the things that we see a lot, and I've sort of seen this across data science teams across Australia, is that you can get, one of the problems that organizations face is, so they hire a data scientist who's a specialist in this particular type of modeling with this particular language, etc. They build a solution, but as data scientists do, they eventually move on to somewhere else. And so the organization then is stuck with this bit of code that may be exceptional, but they don't understand it and they don't know how to maintain it. So there's organizational risk, that's if it's a big enough problem where the organization can afford to go out and find a very, very niche specialist who can support that application, that's fine. But there's a whole bunch of data science opportunities and solutions where they don't really want to do that. What they want is an application that's more accessible, where they can train their own people to use it, and they'll end up with solutions that are more sort of sustainable and
standardized, as you say. So if these people then move away, it doesn't matter, because the model or the tool, whatever solution they built is still there, and you can have another data robot expert coming in and take it from there, right?
Or train your own. The other thing is it's about it's a career opportunity for you. If you've got sort of analysts and BI people who are interested in machine learning, here's a kind of a career step. They may want to eventually move on and build extravagant bespoke data science solutions, or they might quite enjoy the process of using an automated tool to solve lots of problems.
Does DataRobot, I'm assuming they will offer some kind of certification?
Yeah, so we have this whole program called DataRobot University. It begins with this system called DataRobot Essentials, which is a 2-day course covering the kind of the bare bones knowledge to use DataRobot. We've got an accelerated program for data scientists who just want to understand the product itself. We've then got a whole bunch of more niche ones, so that because there's an API, so you can actually interact with DataRobot programmatically.
Interesting. Okay.
Python or R, so you can learn our APIs. There's a time series specialization if you only want to focus on our time series product, and there's a bunch of others coming. We also run this thing we called machine learning for executives. So the idea is to sort of teach senior business leaders, try and demystify some of these concepts.
Yeah, that's great.
Help them understand what they need to do to support machine learning projects, because it's not just a matter of if they don't have the commitment to investing in having the right data sources ready at the right point in time, so that the models can be sort of scored and then integrated with other downstream systems, they won't realize the value. Sometimes the value in machine learning is simply from the insights, but most of the time the value comes from integrating them tightly with your systems, whether that's writing to a database or integrating with an RPA system. There's a whole variety of ways of doing it, but you typically have to do some kind of integration.
That is interesting. Yeah, that's a great way to educate the business side of the people, right? Because especially those who hold in the wallet, they want to know what is the proposition here, what I'm going to get out of it, right? As any other data project, they are thinking, how I'm going to invest this X amount of money on this project and all these people on this data, what I'm getting out of it, right? So that's important to articulate that message.
Absolutely.
Awesome.
Yeah. So the founding story is kind of interesting. That our founders were a couple of data scientists working in the insurance industry, and they were also, as well as kind of building models and doing analytics by day, they were keen Kaggle competitors. So they'd compete. If the listeners aren't familiar with Kaggle, it's an online machine learning competition, and the idea is organizations post data sets, but they withhold some of the data so that you have to build a model to predict something in the data set, and then you submit predictions on this holdout data where you don't know what the outcomes are, and you're kind of ranked by performance. You're ranked by your performance on that data that you haven't seen. So it's a nice kind of blind test. A lot of people can get quite obsessed with it and pour a lot of their time and energy into it, and it's proven to be an interesting way that people can kind of skill up because they get to this sort of test. So they were keen Kaggle competitors and knew a lot of people in the community, and they made the observation that a lot of really good data scientists I've seen made, which is that there are certain parts of what you do that are naturally amenable to some kind of automation. There are certain steps and procedures you take regularly that actually, if you're smart about it, you can write your own kind of pipelines, which is the common name for it, so that you can just rerun the whole process, the next time a project comes along that has similar kinds of characteristics. Okay. So they kind of decided to see how far they could take that idea. Basically, could they automate a process where you take a data set, and as long as you say, here's all of the things you know and here's what we're trying to predict, can you build me some models and come up with a candidate model that works really well for this data set? So that at its core was what DataRobot was, an automation platform for rapidly experimenting with a whole bunch of variations of models so that you could get to an effective model quickly. And then as the company grew, it's kind of expanded out. Like one of the things that we quickly realized was that having an adequate framework for deploying those models and monitoring them once they're in production and easily replacing them, that kind of thing, that was really, really required. And then I guess more downstream things, or upstream, depending on which way you think about it, about the data preparation and sort of how you frame the problem, that kind of thing. So we sort of started in automating modeling and expanding out is essentially what the company does. And really, so you asked earlier, like what it can do for you. There's lots of potential use cases, but there's two kind of core ones. For data scientists who already know machine learning and how to model, it's basically like a rapid experimentation tool. You take a new data set, you throw it at it, and then you see what kinds of modeling techniques come out at the top of the leaderboard. So it's kind of like a Kaggle competition. It internally competes models against each other. Gotcha. And then you see what techniques are working well on that data set. And you can either, depending on the kind of organization you're in and the problem you're working on, you might say, well, that model is, even if you think that you could, if you spend a month on it, you can get better performance, you might say, well, that model's good already. Let's deploy it because there's business value in it straight away, and then we can work on refining it. Or you might say, well, I've got a list of 100 other things that the business wants me to do. I'm going to deploy that. I'm going to focus my attention on these other things. So it's really, in that way, we're focused on data science productivity. And I think one of the things that you and I spoke about a couple of weeks ago is that we're in that game, like a lot of software companies that tend to sort of, you could say eat, or at least sort of automate from the bottom up. I mean, we're targeting, often we help people target the low-hanging fruit, but sometimes that low-hanging fruit is like situations where they've got they've got relatively simple models to build, but hundreds of them. So you take like any organization that's got kind of a rewards program where there's a whole bunch of products that people might be interested in.
Yeah.
You don't have the kind of data that's amenable to those like the recommendation systems that say Netflix or something has. Typically what they're doing is building propensity models for every single product. So a propensity model just means, given this customer with these attributes, what's the probability that they'll be interested in purchasing product X and then product Y, etc. So it can be quite tedious and time consuming
to do it every time manually. Yeah.
So that's a kind of a real sweet spot for us, automating those kind of relatively simple models, but at large scale. Does that make sense?
Yeah, it makes sense. And from your experience in the market, have you seen, because I think data scientists are very hardcore people, in my opinion, right? They like to put their hands on and create the scriptings and play around with Python and R. And there's some people out there that will never go for like a software solution because it's not good enough for me. So have you seen a change in the latest years towards more like adopting these technologies?
Yeah, look, I think that's a complicated issue, and you know, being a tinkerer, I like to build things myself from scratch as well. But I think one of the lessons that most data scientists kind of have to learn as their career progresses is that you also have to be pragmatic. Like you have to use tools that get business value rapidly. And actually, the anecdote that I sometimes use with people is like so. First of all, there's always going to be work for data scientists who really understand these kinds of techniques in detail, because there's always more complicated problems and processes to work on. The danger, of course, is people need simpler projects to start on so that they gain those skills and gain those insights. But the reality of it is that most data scientists today are still using tools that simplify some of the processes that data scientists did 10 years ago. For example, most people today are building neural networks in systems that do automatic differentiation. 10 years ago or 15 years ago, you had to do the differentiation yourself and work out how to calculate those gradients in the neural networks manually. Or I mean, there'd be some packages where it was,
of course, something open source. Yeah.
Novel network, you still had to calculate those gradients manually, whereas now with automatic differentiation, you don't even have to do that. So there's a kind of it's a half truth. So, the same thing goes to say there are really sophisticated tree-based machine learning algorithms which just make it really easy, make it much easier than it used to be 15, 20 years ago.
So basically, you don't have to reinvent the wheel every time. You can just use the tool that has the model that's already proved it works.
Yeah, there's a bunch of very powerful purpose techniques. So,
very cool. So yeah, I think it's important for any person related to data is to be agnostic as much as they can, and be able to and be open-minded and work with new tools as well as traditional tools, because companies spend their hundreds of millions of dollars to create a tool to make your life easier. That's the whole game, right? They charge for it, but that's a hard. In my career as well, I've seen people that they use open source only. They don't use like a Tableau or anything like proprietary. And I was like, why? I mean, you are basically building something from scratch every time, and that's time consuming. You could be using that time more effectively doing other stuff. So that's a good advice for the audience to keep an mind open and look at these tools. So in that regard, the next section here is why data science. And the first thing that I would like to hear from you is, what is your definition of data science and a data scientist? Because I've seen so many in the market and there's a lot of people confused. The other day, a customer approached me and I was like, I'm looking for a data science because I need to build some reports. And I was like, well, probably you don't need a data science for that. So there is a lot of misconception in the market and misunderstanding of these concepts. So I would like to hear from you. What is your take on this? How will you define it?
So I guess the definition I like to use is the one that I guess I think of as the source. Like, the term emerged, I guess, predominantly from tech companies in the US, where they were describing the emergence of this person who was a programmer who kind of understood the tech stack reasonably well, but was also a stats and machine learning hacker to some extent. They knew these algorithms and techniques and the kinds of situations they worked for, but was also sort of business minded in the sense that they really cared about how those techniques would affect a given business outcome. And like people often show that there's a Venn diagram that floats around the internet, sort of showing the confluence of those three things. But really, that's why it was the unusual combination of those three things why they coined a new sort of term for it, because it's the interface between sort of business impacts and the software is assisted by statistics and machine learning. So that's the definition I like, because it also emphasizes why some people felt the desire to create a new name for this thing, because one of the things that you sometimes encounter a lot in extremely technical people, and I've met lots and lots of extremely talented programmers and mathematicians over time who don't really care about the business, how it functions at all. I mean, what they care about is solving interesting problems, and they want to sort of work on those things, but they're not really deeply engaged in the business that they work for, which sounds like a strange thing to say, but sometimes it's just about the personality type of people who are into that kind of thing. So the word and the name for this career exists because organizations were looking for people who would, fit in that niche and help them solve the problems they wanted to solve.
So in your experience and your opinion, do you think that is a qualification or a quality of someone who call themselves data scientists? They need to be more aware or business aware, or is not required?
I think absolutely. I mean, I think there's been the term itself has been somewhat kind of diluted. I mean,
yes.
So what happens is that because there's hype around it, and educational institutions are trying to sort of churn out courses to satisfy the demand for people who want to be data scientists and the institutions who want to hire them. And often those courses are run by people who've never essentially practiced in industry, which is not to say that's a bad thing, but I'm just saying that they don't necessarily know what industry needs or wants. So, and it's much easier to focus on the tech stuff in those courses. So they focus on programming skills, on stats, on ML, they'll use textbook kind of instances, but they won't talk about how you interact with a business operations person and understand where the costs and benefits and the trade-offs and the inefficiencies in the process are, so that you can frame a machine learning problem that can actually help them. They don't. That it's harder to teach, and it doesn't get taught. So what's kind of happening is that's the kind of data scientist that's being churned out, which means that there's the kind of need for the people who can supplement their skill set and actually understand those.
Yep, that's a good one. That's a good advice. Yes, I think in my opinion as well, they need to be aware of, because at the end of the day, we do all of this data X related things to help a business to either grow their business or attract more clients or reduce churn. At the end, there is always a business objective at the end, right? Unless you are in the academia, as you said. But if you're on the business side of things, you are doing this because there is a business objective, something they want to achieve. So it's good. It's important for people to be aware of that, at least understand what the business is trying to do. So I have some more questions here. Like, why did you choose to become a data scientist? What was the thing that attracted you to pursue this career? And then a follow-on question is, what is a typical day in a data scientist looks like?
Yeah. So, I mean, I just fell into it. It wasn't, there's no grand plan or anything. I followed my interests and ended up here. So, I learned to program when I was a kid.
Wow.
So my uncle ran a computer store selling, various home computers, and
Oh,
he
nice.
taught me to program BASIC, and so I used to,
There you go.
write BASIC, uh, and I used to have.
So, by the way, for people out there who doesn't know who BASIC is, it was a programming language that would pretty much speak to the machine itself. It's like a machine's language.
Not quite. It's not that. Yeah, I'm not that sophisticated. Yeah, the BASIC was an abstraction above that. It was assembly language is
Assembly
essentially right
language.
at the machine level. But BASIC was an early kind of high level computing.
Yeah, true.
Language. It was reasonably similar across lots of different systems, but in the this was in the 80s and 90s. There were lots and lots of different kinds of computers that had different versions of BASIC, and you could get, even when I was a kid, you used to be able to get these books, where
with pages and pages of code. You will just write it down. Yeah, I remember.
It was like, here was a game I wanted to play. You had to write code for the game in order to be able to play it.
I did that. I remember saving this code in these cassettes. Remember, you have this cassette and you put it in the console and save your code. That was so hilarious.
It was awesome.
It is awesome, yeah.
You had to really want a game to play it.
You have to program it for like a month and then you can play it.
Yeah, you could buy them, but it was just, the small town I was in, I don't think we had a computer store. I had to my uncle lived in a different town, and so I could get things from him. So yeah, but there was a bookstore, so I could buy these books and learn how to program certain games.
Yeah, that's cool. So how that's your common day looks like, from the time you wake up and you work with multiple customers. I'm assuming the question here, people is asking because they want to know more about, how that day looks like on average day. Do you go and program or create code, or do you just spend more time with customers and trying to solve problems on a whiteboard or things like that?
So it's pretty variable. I'd say my job is not typical of most data scientists, and
okay.
I don't even know if there is like a typical data scientist. I currently do less programming than I used to. So most of my programming is more prototyping or building example applications for people. Sometimes I do, it depends on what the engagement is. So a lot of it, the reason it's so variable is because it kind of depends on what our customers are looking for. So sometimes if I'm just dealing with teams of data scientists, it's more about sort of training them up on new features in the platform, training them up on how to use the DataRobot API in case they want to so you can program applications on top of DataRobot if you want to, and some of the customers do that. Some of it but then on the other end of the spectrum, we're dealing with organizations that are smaller and either can't get data scientists or don't know how to manage them and would rather just have us do kind of consulting for them, use our tooling to solve their data science problems. So in that end, I'm spending a lot more time helping them frame problems, like talking them through the business problem, really understanding where the difficulties are, determining if machine learning can help them, helping them in the data set and build the model. It's kind of end to end. So it's pretty variable. Some part of it's education, part of it's sort of, whiteboarding kind of problem solving as you're discussing. Some of it's code prototyping. Some of it's working with our engineers to help them, integrate the final deployed model.
Yeah.
Lots of talking.
And lots of talking. And probably if you become more senior on this stuff, it's more talking and less doing. And that's usually what happens. So next section is how to get started in data science. So there are some questions here about, if someone is looking into becoming a data scientist or jumping from another career or is coming out of uni, what are some, typical recommendations and, for example, certifications or things that they should be aware of before they start this journey?
Yeah. So that's another kind of a hard question. I get the advice I've given before is that I think people should be very honest with themselves about why they're becoming a data scientist and what kind of work they envisage doing. because the field is massive, and in fact, we're already starting to see it already, that actually there'll be different labels for people who specialize in different areas. And so I wouldn't be surprised if all of the emphasis on data scientists themselves really starts to diminish over time, because people will recognize that actually we need more specific labels for the specific skill sets we're looking for. So, for example, do we want a machine learning engineer? Are we really talking about we need someone who can help us build a machine learning system that can deal with the size and quality of data that we're dealing with and integrate it with the systems we've got? Or are we looking for someone we're trying to design, we're rapidly evolving our product and we want to be able to run experiments with different variations and interpret that data quickly. So it's more like a statistician who's got, who understands experimental design, but maybe with a mix of someone who also understands sort of products and technology as well. So there isn't really a label for that, but that might be something like sort of an experimental data scientist. And there's some who just sort of focus more on visualization. Like it does get kind of sort of downplayed a lot, but there's a lot more to data visualization than most people give credit to, which is not to say that everyone who does data visualization does it well. You see all kinds of
stuff. Yeah.
Done. So there's definitely a space for people who are genuinely very good at that.
Yeah, and in the past when I was working, especially with Tableau, I encountered a lot of data scientists who were having a lot of issues presenting. And the main question is, how can I make this attractive? How can I make my findings and my data, my research, my prototype, whatever, easy to understand? Because they were trying to use R and a library there to present some graph, and it's not friendly, right? It does the job, but for an audience that is uneducated on this stuff, it's like, I can't use this, right? So that's why I think that's a good topic. It's a good idea to partner up with someone else, with other people who are maybe skilled in other areas. So interesting that you see that is. Sorry, go ahead.
Yeah, I was just going to say the reason that I think that's one of the problems you do sometimes see is that people who build data visualizations aren't aware of the various kinds of biases and kind of statistical problems that can creep into visualizations. Like, it's very, very possible to build a visualization that tells the story you want to tell.
Yes.
It actually is kind of distorting.
You can play with so many properties like color, shape, size. You want to emphasize a data point, you can make it happen, and people will believe that because that's what you are representing on the screen. So that's when best practices come in and all that. So that's for sure something that I will advise as well to data scientists. Focus on the data, focus on creating good prototyping, but also learn how to present your findings to executives, right? To uneducated people who are not experts on data science. That's a good one. Okay, let's move on. So how to get started? Well, we'll discuss about how the robots compare to others. What are let's move to section 4 here. What are the challenges of data science and data scientists during the COVID era? Right. So I'm assuming your company, as many others, have been impacted. But what are some of the recent challenges that you face, or some of the questions that you are receiving from prospects, from customers related to COVID?
Yeah. So I guess the most obvious challenge is that it's a kind of a real rubber hits the road kind of test, because you'll find out whether the organization you're working for is really dedicated to this stuff, or whether it was just kind of like a side.
Gotcha.
So definitely people who've lost their jobs or have suffered, like a downturn in the amount of. But aside from that, I guess the core. There's two kind of core underlying problems that data scientists are facing at the moment. One is changing priorities. So organizations they've spent all the last 6 months, 9 months working on some project, where now the business landscape has changed. All of a sudden, that project is totally de-emphasized, and they've got something to have to focus on. So they've got to turn around and change their emphasis, which is not necessarily a terrible thing. It's nice to have new things to work on, but it does mean that, you know, like they may have they've got shorter time frames to deliver results because urgency's kind of crept up. Which brings me to the second point, and that is that the big problem that I would say many data scientists would be facing at the moment is that when the world changes, the data changes, and, you know, consequently the models kind of need to change. So certain organizations, like if you were building models to forecast the customer demand for flight, for example, for an airline, then clearly any model you built last year is going to be broken this year. So it's really only, so anyone who is doing modeling that's related to human behavior, so if it's regardless of whether it's a telco or it's a bank, it's an insurance agency, insurance company, etc., they've all got changed data. It's only, I guess, the data scientists who are working predominantly with physical data. So you're trying to predict, you know, the likelihood whether a component in a kind of oil rig is going to fail at any time. That won't have been affected so much because it's something that's impervious to these changes in behavior. But yeah, so like I guess what we're seeing is a lot of, and I guess because, you know, what a lot of companies are thinking through at the moment is the business landscape has changed, which means that maybe they need to be more worried about what their competitors are doing at the moment than otherwise. They might say, well, look, the size of the pie, as in the amount of money to be made there, has shrunk a little bit, which means they need to start focusing on making sure they don't lose their market share. That's one of the things. That's what I guess one of the key things we're seeing at the moment.
How they can retain their market share and retain customer retention, probably one of the biggest challenges right now across industries. So would you recommend a company that doesn't have, or there are so many people who don't believe on this? No, I don't believe in that. I've been in business 20 years. Why should I adopt, you know, data science? Or what would you say to them?
Yeah, so I'm not. I wouldn't. I don't. It may seem kind of non-self-serving, but I don't adhere to that idea that absolutely every company in the world needs to adopt data science across every line of business currently. Like, I think there are trade-offs. Data science works well whenever you can see there has to be opportunity, and that opportunity has to consist of either costs and inefficiencies in how you're doing business. For example, you've got, like, you take, you know, consider sort of anti-money laundering or fraud in a bank. They've got large numbers of people who have to manually review all kinds of transactions, constantly looking for these problematic records, and that's time consuming. It takes lots of time to do that. It's hard for them to keep expanding their team as their business grows. It's not particularly rewarding work for a lot of those people. So they've got to deal with that. There's a massive cost there, and there's a growing cost. It doesn't scale in a particularly fantastic way. So anywhere a business says, look, as we scale our business, our costs are kind of scaling alongside it in uncontrollable way. There's a data science opportunity to say, okay, how can we take the people who do that job and try and automate, at least relieve some of the pressure on that job, so that as we grow, we don't need to scale that team at the same rate, and that means profitability. So often there's a real focus on that. And then obviously anything that's kind of revenue based, like being able to basically optimizing your marketing. I think just knowing who to target, when, with the right kind of deal, maintaining customers through retention. Those are all kind of vanilla data science problems that that most organizations have in one way or another.
That's interesting. So one more question here is around how do you see, and you probably explained this already, but how do you see data science evolving in the next few years? And I know that it's already been evolving towards ML and AI, but what are some maybe clear changes that you see happening in the market that it could help, younger people who is just getting started to really focus their career or selecting a path, right? So because here as I mentioned before, I have this Data Squad Academy where we are teaching not just technical skills to people, but also business skills and how to become a leader in the data space. So what are some clear patterns being a data scientist that you can perceive and see in the market that are going to drive changes in the next, 5 to 10 years? Especially as we automate more and more of the work, right?
Yeah. So there's, I mean, it's an opening space, all right? Like we're not even, the kind of stuff we do is not the whole picture. DataRobot's, there's other kinds of data science, like we mentioned, sort of implementation and visualization as two kind of key ones. There's also sort of optimization and simulation. So one of the things that we've seen a lot of is that sometimes people use models, they do machine learning, but that's one layer of the data science part. They then run simulations or optimization on top of those models. So we've been building applications for standard use cases to help people do that. But there's a lot of opportunity to do that in very bespoke ways in different industries. So I think there'll be a lot of growth there. I don't know how quickly that will happen. It's really hard it's kind of hard to read, especially now with the whole COVID phenomenon and kind of pulling back. I think there'll be more focus on making sure data science teams, I guess, do the things they were originally created for and do it well and do it in a repeatable fashion and really kind of locking down on that value. So for all of those kind of vanilla modeling types of systems, like customer churn, like sort of marketing propensity models, fraud, anything kind of.
I've seen a lot of requests for resilience models. So organizations, they want to become more resilient and as you said, avoid churn if they can and optimize their operations. So logistics and purchases and all that. I've seen a lot of those requests coming in. Like, I want to know now, I need to really pin down the providers and the suppliers and really pick the one that is the cheapest, but the best and all of that. So yeah, I guess in the next year or so, that's what we want to see more of that. But yeah, I think AI is in the world. Everybody's talking about it. Everybody's like trying to use some kind of machine learning AI. So I reckon most of the data scientists will start converting towards that because that's where the market is going as well. It's interesting to see. Yeah, it's going to be an interesting few years ahead of us. So one more question here for just closing up now our conversation in terms of tips and recommendations. What are some learnings, and maybe you can look at this in this aspect. What if you could talk to the little John, 18 years old? What would be the advice? And then he's telling you, John, I want to be a data scientist, right?
Yeah.
What would be some advice that you will give him? What are some common pitfalls that you will say, hey, be aware of this, be aware of that, and not be afraid of being personal as well. We want to also provide our listeners with a more personal approach, not just professional, but also, there are some personal things that you can be aware of.
That's a really hard one.
You will say, don't do it.
No, I certainly wouldn't say do it. I mean, it's funny. I think about different kinds of advice I'd give myself at different points in time. Like, so for example, there was a time when I used to spend a lot of time building neural network models. And then for a while, it got to the point where it was just much you could, like, if you knew SVM, because of the size of the data sets I was working with, I could get very similar, if not better, results very rapidly using SVM models. And I gradually turned away from neural networks and didn't kind of foresee how much of a comeback they'd make, really, when it was just about basically the size of the data sets and the size of the computational processes available. So sometimes I think I'd say to myself, well, probably should have stuck to focusing on that stuff a little bit longer. Hard to say. I mean, it's so accessible to use them. I'm using them again now, so that's not a big deal. I think the one thing that I would give, the one advice that I would give anyone about data science is that, aside from those kind of core skills, the generic skill that seems to be hardest to acquire for people is statistical intuition. So what you will see over and over and over again is people making mistakes because they don't think about statistical bias and the differences and like how data is being gathered and what that process of the data being gathered can tell you and what it can't tell you. And those intuitions are critical in many, many circumstances for whether the project you're working on is going to be a success or not.
That's interesting. Yes. I was thinking about this video that I saw the other day, someone explaining a dashboard with all the COVID cases. And it was interesting because he was making an inferring some results out of this dashboard that was publicly available by Google, I think. So he was saying, as you can see here, the patterns show us that the richest countries have more cases than the poor countries. See? So something is weird, right? Because poor countries should have more cases, but they have less. And I was thinking to myself, well, what's usually happening in the poor countries is they have also poor health systems, right? So they are not informing the cases. It's not that they don't have one. It's that they don't maybe not even aware of it. So that's the kind of the risk, as you said, and probably that knowledge and that is you have to reach it by experience, right? You have to go through the fire of multiple projects. So when you see patterns that are maybe not realistic, you can say, this is something that could be a bias here that I'm not aware of.
Yeah, I mean, and it's multiple things, because in that case, like the COVID thing really it's been like a canary in the coal mine for a lot. Like you just see, like, so one of the critical things is sort of comparing countries at the same point in time, but not considering the fact that the first case, when the number of cases first started, epidemiologists typically do is compare to the number of days since the cases reached some certain kind of threshold, whatever they consider critical. I didn't know that prior to the whole COVID thing, and just reading about the way epidemiologists present this data. That's one key thing they do to try and overcome that bias of the fact that the cases, they come into different countries at different points in time. But other simpler things, like people love to talk in absolute numbers but not talk about the proportional to the population size. And you could even take that further and talk about like population density, because that's also kind of probably critical as well as things like just all of the potential, the data collection biases about, as you say, exactly, like it's reported and how efficient their healthcare system is at reporting. One other thing I read about was just that the standards across countries for how they attribute the death varies. So like there'll be, because often there's, with influenza, there are other kind of contributing factors. So Correct. It could appear by some other kind of, by some other factor. So, but the way that is calculated and captured by different countries varies. So you've even got that bias.
Like so many bias.
Do not envy epidemiologists at all. It's an absolute mess.
Actually, there are some countries that, especially in South America, I'm from Chile, and there are some countries over there that say we are not going to publish any more data on testing. We don't just see they just stop reporting.
Yeah.
Why not? I don't know. So then if you look at from the world perspective, you say, oh, look at that this country X has so many less cases than last week. Well, they stop reporting it. So that's Yeah, I think data scientists and anyone working with data needs to be careful about that, right? Before making any suggestions or pushing people to make decisions based on something that could be flawed. So that's
Agree. And I think it's even more than that. One of the other thing that I think is critical about this often is that it's almost like a personal quality that a data scientist should have, and that is skepticism. If you build a model and it looks good or it looks amazing, your first thought should not be, I'm awesome. It should be, I've done something wrong.
okay.
That's your first thought every time I've done something wrong. You have science is based on skepticism. You have to doubt it until you can't prove it wrong, and then tentatively accept it.
That's a good advice. Is there anything, any book or author that you would recommend people checking that it helps in your career? In top of your mind, maybe there are so many, right? But maybe the top 2 or 3 that you recommend.
I guess it depends on what you're looking for. The one thing that springs to mind is for a while there, I used to read a lot of the books about Richard Feynman, the physicist.
Okay.
Because he was a really unusual character. And there's one, I think it's the book Surely You're Joking, Mr. Feynman, which is a collection of kind of stories about him and his life. And one of the things that I really like about that book, I think it's that one, there's an anecdote in it that he tells about when he was a child. So his parents were not scientists. I can't remember exactly what career they were. I think kind of blue collar workers, but interested in this kind of in science and knowledge, but they had a really unique way of imparting upon him some key scientific ideas. One of them was he relates a story where he went walking in the forest with his father, and his father was pointing out various animals and birds, and he'd say, that's the name of that bird is such and such, and its scientific name is such and such, and maybe it's called this in some other language. And then he'd say to Richard, so what do we know about that bird now? It may not have been birds. I can't remember exactly what the kind of animal it was. And then Richard would, shrug his shoulders or whatever, and his dad will say, we know nothing. We just know what it's called. So if we want to learn something about it, let's sit here and let's observe it for a little while. So they sat down and watched the way it behaved. So like imparting on him from a very early age importance of not thinking just because you've learned the name of something that you've kind of like conquered it and you understand it, and that observation is critical to sort of becoming more familiar with the world.
That's a great advice. And I think the problem with that is today's market, nobody wants to wait, right? We want instant gratification, instant results. So as a consultant, you go to a customer and, okay, you have 5 days to deliver this list of insights. I need to make decisions now. And I get it. They have pressure, the market is pressuring their situation. But how important is, as you said, sit down, observe, and then start working on something.
Yeah.
That's great. Great advice. Yeah. Okay. Thank you, John, for your time today. I don't want to take more. We have been talking for an hour already, and I appreciate your time, your ideas, your teachings, everything. And so I think people can reach out to you on LinkedIn, of course. I think you also have a GitHub account that you mentioned.
It's like there's a github.io, so I've got a website on GitHub that's got sort of.
I will make sure to put that in the link so people can follow you or reach out to you.
My Twitter in there. There's linked to my publications and talks I've given, and also books. So I've got.
Really? I didn't know that. Okay.
Yeah, so I recently wrote a kids book with my kids, which are all the proceeds of which I'm giving to the charity Oz Harvest, which basically who sort of work to fight food wastage and feeding the homeless.
Oh, nice.
Money, buy that from the website. And I also have there's links to also, I've written some zombie comedy novels as well.
Oh, cool. I would like to read that one.
Yeah, so if anyone has it's a very, very niche interest, but if you like zombie comedy, then...
I know few people who can be, very excited about that one. So thank you, John, and have a great day, and thank you for sharing your thoughts today with us.
Yeah, likewise, Christian. Thank you. Cheers.
Thank you for listening to the Data Squad podcast. I hope that was insightful and you learned something new today thanks to our guest speaker. Now, just as a quick reminder, if you want to learn more about the Academy, you can go to academy.datasquad.com.au to learn more about the different courses that we provide. At the moment, we have two different options. One is the called Data Mastermind Group, which is basically a subscription offering that we provide for you. So you pay monthly and you join a community of like-minded people. Now, the Data Mastermind is a monthly subscription that it will allow you to see new content and receive new content in your dashboard every month. All of this content is video based, so it's not going to be PDF or documentations, although we are adding templates and cheat sheets for you to work and develop your skills in different areas. Every month we are going to have a different topic in the Data Squad Academy. The other course that we are launching now is the Mastering a Data Culture, and this is a standalone course, and the purpose of this is to teach you all the tricks and ideas that you can implement in your organization to become more data driven. Over the years, I've been collecting this information thanks to my work, and I'm putting everything that I know in this program. This is a 7 modules program, and every module is designed to teach you different skills from technical to non-technical, how to create a team, how to lead with data, how to create and work processes and platforms and all of that. So check the link below, and if you are listening to this, you can go to academy.datasquad.com.au and you will see the different courses there. I will see you in the next podcast. Thank you.